Welcome to this lesson on worker node components. In Kubernetes architecture, worker nodes are where your containers actually run. These nodes contain three essential components that work together to make this happen: kubelet, kube-proxy, and the container runtime. Understanding these components is crucial for mastering how Kubernetes manages and runs your applications. A worker node is essentially a machine in your Kubernetes cluster that runs your containerized applications. Think of it as the workhorse of your cluster. Every worker node has three critical components installed on it. First, there's kubelet, which acts as the node agent. Second, kube-proxy handles networking. And third, the container runtime is responsible for actually running the containers. Together, these three components ensure your applications run smoothly and reliably. Kubelet is the primary node agent that runs on each worker node. You can think of it as the captain of the ship for that particular node. Its main job is to ensure that containers are running in pods exactly as expected. Kubelet acts as the communication bridge between the Kubernetes control plane and the node itself. It receives instructions from the control plane and makes sure those instructions are executed properly on the node. Kubelet has four main responsibilities. First, it registers the node with the API server, making the control plane aware that this node exists and is available. Second, it continuously watches for pod assignments from the API server. Third, it starts and stops containers by communicating with the container runtime. And fourth, it reports the health status of both the node and the pods back to the control plane. This constant communication ensures the control plane always knows what's happening on each worker node. Kube-proxy is the network proxy that runs on each worker node. Its primary purpose is to maintain network rules and handle communication routing. Kube-proxy enables the service abstraction in Kubernetes, which allows you to expose a set of pods as a single network service. Without kube-proxy, the networking magic that makes Kubernetes services work wouldn't be possible. Kube-proxy performs three critical functions. First, it manages IPTables or IPVS rules for traffic routing on the node. These rules determine where network traffic should go. Second, it forwards incoming requests to the correct pod backends that are actually running your application. And third, it enables load balancing across multiple pods, distributing traffic evenly so no single pod gets overwhelmed. This ensures your applications remain responsive and highly available. The container runtime is the software layer responsible for actually running containers on the node. It's the engine that powers your containerized applications. The container runtime handles tasks like pulling container images from registries, creating containers from those images, starting and stopping containers, and managing container resources. Without a container runtime, your containers simply wouldn't run. There are three popular container runtimes used with Kubernetes. First is Containerd, which has become the industry standard runtime. It's lightweight, efficient, and widely adopted. Second is CRI-O, which is a lightweight runtime specifically designed for Kubernetes environments. It implements the container runtime interface specification. And third is Docker Engine, which is the popular runtime many developers use during development. While Docker was the original runtime for Kubernetes, modern clusters typically use Containerd or CRI-O for production workloads.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.